Okay. Next, we're going to look at the emerging opportunities in obesity treatment. And Dr. Stephen Heymsfield, who's a professor and director of Body Composition Metabolism Laboratory at the Pennington Biomedical Research Center at Louisiana State University. Your card probably is pretty long, too. Dr. Heymsfield received his medical degree at Mount Sinai and completed his internship, residency, and fellowship at Emory. He later moved to the Columbia faculty, where he was a professor of medicine. He's, again, got more publications than I particularly care to read, and he is the vice president-elect of the Obesity Society. So, Dr. Heymsfield.
Thanks very much. An interesting meeting with my senator yesterday in the Hill, who was a former colleague at Pennington, and reminded me that obesity is a lack of willpower, and that we wouldn't have so much obesity in Louisiana if it wasn't for the food stamps. And, you know, it's an interesting idea to think about our inability to understand obesity in any one individual person. We still don't really have a good handle on that. We lack the tools to uncouple the different environmental and genetic causes. And so it's a very interesting, challenging field to work in and to find targeted therapies that work at an individual level. I'm going to talk about that a little bit. I do have some disclosures. I'm the medical advisory boards of 2 companies, unrelated to my presentation. So coming back to this idea that obesity is a problem of excess adiposity, and we use a very simple shape index, body mass index, to quantify it. And if we think about the causes, again, of any one individual gaining excess weight and becoming obese, we know that there are at least 3 big columns here are genes, and how the genes are modified after they're formed by epigenes. These are environmental effects that modify the way the genes work, and the environment. And these factors all interact together, and we can call these interaction terms. And when we put all of those together, there are literally thousands of potential ways any one individual person can become obese through all of these interactions. And what we're really looking for in treatments are very strong effects, innovative ways to overcome these thousands of interactions, or on the other hand, trying to decipher in any one person what the underlying causes of their obesity are. So this is a tremendous scientific challenge. But if we think of the strong effects, we know that at birth and early in life, there are some children who become massively obese. They have zero control over their food intake. They have a problem called hyperphagia, and they become massively obese. Many of them die very early in life. And we know that there are 10 or 20 of these genetic abnormalities in which there's often a single amino acid defect in a hormone, this particular hormone being leptin, the so-called genetic defect, obese genetic defect. Single amino acid derangement leads this person to eat out of control without any environmental influence. So we know that genetics plays a very strong role, and that there are people who have single defects. And we can see that in these 3 adults, A, B, and C, who had that defect and have zero leptin levels because of it. When you give them leptin, very small physiological doses of leptin, their weight becomes completely normal. They undergo adolescence, so to speak, because adolescent development is prevented by a lack of leptin, and they become basically normal people. These are the effect size every pharmacologist dreams of. And very few opportunities have presented itself like that, but it just shows it is possible. These 2 children have a defect in what's called POMC. It's a peptide made in the brain, and it splits off to make very critical factors that regulate food intake and energy expenditure. and it's associated with the red hair color. And likewise, they become massively obese early in life. And the POMC, this little cartoon shows what's called the homeostatic mechanisms that that control food intake in the what's called the arcuate nucleus of the hypothalamus, a very small area that regulates food intake and energy expenditure through counter-regulatory pathways, and the signals coming from the periphery. So this is a critical section of the brain that regulates body weight. And there's a single mechanism shown here in this red circle, the melanocortin-4 receptor. And that is deranged in these children. The signal going to that is abnormal. And it's been an extraordinary challenge to find a drug to activate that receptor and turn off hyperphagia and massive obesity. And this particular drug, it's a peptide, setmelanotide, it's very recently introduced, was shown in these children to, this on the left shows their massive weight gain. This is normal weight children versus age. This is their massive weight gain. And when they were given setmelanotide subcutaneously, their weight basically normalized. This is a curative mechanism. So very powerful effects in genetic mutations. And it shows that we have the ability to have targeted therapies. And importantly, 2 to 5% of severe childhood obesity involves this mechanism, or a very closely related mechanism. And there's now a project to collect and create a repository of people who have these mechanisms as these drugs come forward. So this is a very exciting cutting edge of pharmacotherapy. Now, if we move to another area, the peptides, these are small proteins basically that are, in this case, made by the gastrointestinal tract. There's a whole family of them. Glucagon-like peptide 1, GLP-1, is one of the more prominent, and it has effects on glucose metabolism, that is diabetes, and obesity. And this glucagon-like 1 peptide is shown here. And if you give GLP-1 to people, as in Saxenda, which is liraglutide, it's a peptide now used for treatment of obesity, you can get nice weight loss over time. This just shows that it produces weight loss. And you can inject this subcutaneously once a day or twice a day, depending on the drug that you're using, and you can get this very nice weight loss. And this is the most potent of the monotherapies for obesity that's currently approved by the FDA. But there are new GLP-1 analogs. For example, setmelanotide, made by Novo Nordisk, is a long-acting one, and you only need the injection once a week. So this would change things very radically. Instead of every day or twice a day, you could inject this once a week. So this is sort of the first wave in emerging therapeutics. Now, there's another challenge. This is one of the holy grails of peptide, like insulin's a peptide, and you have to inject it. And there's been a dream for many, many years. Why can't you take it as a pill? And the reason is peptides are digested in the gastrointestinal tract, because the gastrointestinal tract eats proteins, of course. That's how we digest them. And the acidity is high and so on. And there's a challenge to making an oral peptide. And in this area, there's been developments in creating stabilization factors that wrap around these peptides and prevent their digestion by acid in the stomach and facilitates their absorption. So there's one in development that takes a drug like semaglutide that I just described and coats it with what they call a snack. And it's a way of preventing the autodigestion in the stomach and facilitating the absorption by the GI tract. So there's an oral version of semaglutide co-formulated with this absorption enhancer called a snack, which changes localized pH and leads to absorption. So this is the next wave, not just once a week, but once a week oral pill. And there's been some preliminary work These are the currently available drugs that we have. Here's the placebo effect on percentage at 1 year that lose weight. You can see 50 or 70% of people lose 5% of their weight. And liraglutide here, the only peptide injectable we have, is actually the most potent monotherapy approved by the FDA. And these are combination treatments below. But this is the most potent. It's a rather expensive way of managing obesity once a day. But as I mentioned, there's once a week coming online, and there's once a week oral potentially coming online. And so here's some early evidence, 25-week study in diabetics. This is comparable percent losing 5% or more. And this is the subcutaneous injection of this semaglutide subcutaneous, and here's the oral version, almost the same amount, if not more more weight loss. This is a very promising area, again, potentially years off, but definitely in the later stage pipeline. This little complicated slide shows similar study. Subjects were about roughly 100 kilograms to begin with, showing that placebo, and this is subcutaneous semaglutide once-a-week injections, and here's the oral version. So there's very promising therapies that you could actually give a peptide through the oral route that will not be digested by gastric secretions. Now, another very important concept that developed in this area is there are different peptides that are potent. For example, leptin, as I mentioned earlier, is a peptide that, or protein basically, that can be given and cure obesity in leptin-deficient people. And the ideas come up is, what if we weld two peptides together and make a double agent or a triple agent or quadruple agent? This idea has been around for a while, and it really started with these gastrointestinal peptides like glucagon, like peptide 1, GLP-1, made by the gastrointestinal tract. And this is a GLP-1 agonist like liraglutide over here. And then if you put it together, you can get with a glucagon receptor, what's called coagonist, you can get a double peptide. You weld them together, or you synthesize them this way. That's a double peptide. And you can even make triple peptides. This is a triagonist, triple agonist. So this is, again, an idea been around for a long time, but to actually successfully do it has been extremely challenging scientifically. And there's so much development in this area. For example, I found 23 GLP-1 peptides in development, like liraglutide. And some of these, for example, one is called oxyntomodulin. It actually has two active pieces, and I'll show that in a second. And so there are a number of these that are in development that are looking at single agents, combination agents, and so on. Here's another group, peptide YY and NPY. These are orexigenic or hormones that stimulate either food intake or block food intake, and so on. And the one in most advanced development is a dual, it was called a coagonist. And if you activate the proglucagon peptide in the brain, it actually, this proglucagon peptide in the brain breaks up into different peptides, 3 or 4 different peptides, each of which has effects on glucose metabolism and body weight. And you can, here's the GLP-1, it acts on the GLP-1 receptor. This is oxyntomodulin, it's another breakdown product of that proglucagon, and it works mainly on the glucagon receptor, but the GLP-1 receptor as well. And then you can weld these two together synthetically and make this drug ZP2929, which is Zealand Pharmaceuticals is developing this. Works on both receptors, and you get double the amount of weight loss, basically, by putting the two of them together. So here's some early trials in the diet-induced obesity model and in the rodent model. Here's the placebo weight gain. This is just the single agonist alone, GLP-1 like Saxenda, and here's the dual agonist, the two of them together. So these trials are phase 1, going into phase 2, plausibility trials. Now, if we take a little different type of mechanism, there's a group of agents that affect a receptor in the kidney. It's the SGLT2 receptor. And this receptor is very important for reabsorbing blood sugar as it passes through the kidney. You want to preserve your body energy stores by reabsorbing sugar. And you can block this receptor, and then people urinate out several hundred calories a day of glucose. So this is a very effective treatment in diabetes. It has a number of limitations, but this is an important receptor. Block this receptor and you get glucose in your urine, roughly 300 calories a day. So there's that receptor. Now, a fascinating thing about treating people with a SGLT2 inhibitors that are now commercially used for diabetes is that when you increase urinary excretion of glucose, output of energy, there is a fascinating mechanism which tells you that you're losing energy in your urine and counter-regulates and makes you eat more. The same thing happens when you exercise. When you exercise, you eat more by counter-regulatory mechanisms. And this has been revealed here. So when you get an SGLT2 inhibitor, you lose some weight, but not as much weight as you would predict because you're subtly, unconsciously eating more. That's called counter-regulation. And so there are a number of these SGLT2 inhibitors in development. There are 4 of these that I know of that block the SGLT2 for weight loss. And also, you can combine these then and try and block that counter-regulatory effect. And these are 2, this is a GLP-1 agonist. Phentermine you've heard about earlier. It's a sympathomimetic drug. And you can combine them with the SGLT2 inhibitor. And here's some early human phase 2 trials going into phase 3, looking at, this is placebo, this is canagliflozin, which is an SGLT2 inhibitor alone, and this is phentermine alone, and this is the two of them together. And you get a very substantial weight loss in that critical range of 5 to 10% weight loss, at least at 6 months. So these are emerging therapies. These are known mechanisms, known agents, FDA-approved agents. Now, most of the mechanisms we hit aim close to the homeostatic part of the arcuate nucleus. This cartoon again here, a little complicated, but again it shows the arcuate nucleus. And in the arcuate nucleus is a receptor called the Muopioid receptor. The Muopioid receptor is related to hedonic mechanisms, that is, liking food, as opposed to, and it connects much higher orders in the brain that have hedonic effects, liking food, and so on. And it's a hormone used, it's a receptor studied extensively in the area of addictive behaviors. And there's a compound that blocks the Muopioid receptor, this GSK498, that, and I'm showing this more as sort of instructive, that you don't have to block the homeostatic receptors only, and they've been able to show in clinical trials, this just shows hedonic effects like eating fat meals and so on. They got significant effects with this drug. It didn't cause weight loss, but it did block some of these so-called hedonic mechanisms, having significant effects in those pathways. And in this particular study, they were able to show that people experience weight loss who had particular mutations in their Muopioid receptor pathways. So this is a combination of pharmacogenetics. Very early work, but promising. And these type of drugs could be combined with currently available agents like bupropion. There's another area which I'll throw into this category, which is you can take a pill that has a highly hygroscopic compound in it. It expands like a sponge in your stomach when you eat it, gelicysts in development, and you can show it affects appetite ratings, and you get some modest weight loss over time in trials like this. So this is a non-absorbed agent in clinical trials. Now, to sort of round this out, we now know that there are hundreds and thousands of pathways that regulate weight, and we can uncouple these looking at genomics, metabolomics, proteomics, and different omics, and you can generate large data sets, big data, and that ultimately determines our metabolic functions. And so there's a big thrust in trying to find pathways, nodes that regulate energy balance. And the drug companies are looking very aggressively at looking these different omic pathways, putting them together in large data and trying to ferret out whether in fact it is the food stamps or it's your MC4 receptor in an individual person. That is really hard, but that is the direction that science is going, and will eventually have personalized medicine. Now, in the last section then, there are devices too for inhibiting food intake, and I'll go through these fairly quickly. Balloons, very old technology. You put a balloon in the stomach. This is the reshape balloon, and I'll explain that in a second. They're roughly similar, and this is what's called the Orbira balloon. You can put these down endoscopically or have people swallow them. They blow up. You can put them in several times over a period of 6 months. They're for short-term use. They're usually in BMI 30 or more, and generally they're kept in 6 months or less. And this just shows a weight loss curve over 6 months for the Orbira system. And the importance of this is that, again, it's in that 5 to 7% weight loss, perhaps over 6 months, over placebo. So they're modest effects. This one comes in a pill. You can swallow it. Then the balloon is blown up with nitrogen gas or some inert gas, and it stays in for 6 months. You can do it multiple times. This just shows a weight curve over time of a typical study done. And this weight loss range, again, is about 5 to 7%. So these technologies are now approved by the FDA. You can stimulate the vagus nerve in the gastric region with this device. It's called Vblock. It's called a Maestro system, and the Vblock system then is put in surgically. This one can stay in longer, and it also gives a weight loss in the range of 5 to 7%. In the surgical world, Bruce Wolf might mention this later, they talk about percent excess weight loss, but when I translate it to more typical terms, it's in that range of 5 to 7% moderate weight loss. This is the most recent approved one, the Aspire Assist. Basically, you put what's a little sham fistula in the stomach, you drain out the food contents, and then you can get your couple of 100-calorie a day deficit like this. This one's meant to be a long-term treatment as well. So innovation, that's all I can say. Creativity is booming now with the need to curtail the obesity epidemic. So this gives you, here's the Aspire device. Endo barriers, not yet approved, I don't believe, but this one you suture in, and it creates sort of a shunt from the stomach down into the small intestine. This one's also been shown to produce significant weight loss and reduction in diabetes. So in the last second then, Sue talked a lot about lifestyle modifications, so we heard more about it in pediatrics as well. The classic model, as Gary Foster said, you have a stimulus, the behavior is you eat, and then there's some reward or consequence for that. It's called the ABC model of behavior, and that's typically worked with food records. You write down what you're eating, where you're eating. The interventionist then looks for a way to give alternate rewards and reduce your weight. Now, we know that's sort of the old style. If we go to today, We have standing desks, we have Fitbits, thousands of different ways of putting into the behavior modification model. We have websites, companies are building these, and so there's a tremendous wave of interest in behavioral therapies. We know very little about how effective they are. We're beginning to learn somewhat. We have sleep as a way of, we know too little sleep leads to obesity. We're getting sleep treatment programs, behavior. We know that we have a physical activity plan, the YMCA programs. These are all building around the behavioral lifestyle management and hopefully have some effect. We have financial-based incentive approaches. Kevin Volpe, University of Pennsylvania, he's done a lot of work with this. We know that we can take MRI scans of people and look at their behavioral responses and predict whether or not they're going to respond to certain treatments, very early stages. And finally, the great experiment in Mexico with the taxes and the reduction in purchases of sugar-related foods over the last 2 years, showing that the decreased 5 or 10% in those purchases. So those may all have effects. And these all build around behavioral models, and hopefully there'll be some improvement there. And lastly, I want to just put a plug in that these treatments need supervised medical care. It's very important that we have trained physicians and other healthcare workers. There's a wave of certification. Bob Kushner here, American Board of Obesity Medicine, another critical need for trained experts who can manage obesity in these complex mechanisms we're developing. Thanks very much.